Yeah, I think we can start.
Okay.
We can start. Yeah.
Do you want me to just so I'll just sort of give a kind of rough idea about what I was going to talk about today. So I was just going to introduce a little bit about myself, who I work for, what we do, and then I was going to try and give a live demonstration of the platform that we're building. The thing with live demos is there's always a risk that it goes wrong, but I quite like the risk. So let's see how that goes. Um, so yeah, so maybe I'll just start by saying before. So I do have a presentation which I'll probably put some slides up and I'll try and share my screen so that I can show the demo. But before that, I'll just start by saying that hello everyone. My name's Tom Red. I work for an organization called Hub Ocean, which is a non-profit foundation based in Norway in Oslo. And we're a member of the Iliad project, specifically working on the kind of the architecture of building digital twins of the ocean. And I'm going to give a sort of a few slide introduction on what we do. And kind of like I thought what I would actually do is not really focus so much on our role in Iliad, because I just wanted there are a few other things that I wanted to focus on. Oh dear, that's not working so well. You can see my presentation, but I actually can't. Oh, there we go. That's better. I've got it. Yeah, so as I say, Hub Ocean. So we have a vision of becoming a ocean data collaboration hub for the world. So it's a fairly big vision. We're founded by World Economic Forum, which some of you may have heard of. We support big initiatives like the UN Decade of Ocean Science, and we lead a couple of other initiatives like the Ocean Data Platform, Ocean Data Action Coalition, and we're building this thing, as I mentioned, called the Ocean Data Platform. That's our kind of big thing that we do. I probably don't need to go through all of this with you guys. You probably know all this stuff, how important the ocean is for life on Earth, how it contributes to well-being, whether that be through just providing ecosystem goods and services or nutrition, and also it's incredibly important for our global economy. I think what we don't have is the stat of 90% of global trade is conducted on the sea. So I don't need to tell you, but the ocean is very important, but it's also under threat. We have kind of 6 goals that are aligned with sort of several high level kind of things, but they kind of fall into the domains of mapping and managing the ocean. How do we build out the renewable energy that we need by 2050 in a sustainable way? Addressing sustainable food and transportation, making sure that people who are investing in the oceans do it in the right way, that they pick the right companies to invest in. So how can they be confident that which offshore wind farm developer they pick is going to be the one that mitigates any potential impact on the environment, that kind of thing. And also like how companies can actively reduce their emissions and pollution. I didn't sort of say, but maybe now's a good opportunity to go back and say what I do. So I'm the ocean governance manager here. So all of projects that we have that kind of fit under a ocean governance domain is kind of for me to deal with. I have a background in ocean science and a bit of a specialization in international law for the oceans. And I've been working for Hub Ocean for about 3.5 years now. And before that, I had some experience working in funding for marine research, so putting together sort of calls for proposals and things like that. So I have a bit of an ocean background, but in a little bit of different context each time. So what are we trying? What problem are we trying to solve fundamentally at Hub Ocean? So you probably, those of you who work with ocean data, like who have been kind of like doing anything in your studies with working with data, probably have found that it's a real pain. And our hypothesis is that scientists should be spending their time on science rather than cleaning data and setting up complex computers to run analytics on it. One of my colleagues said that there's this stat that says that data scientists spend around 40% of their time just with data wrangling tasks. And actually, speaking to people, we think that that number is actually higher. It's more like 70 or 80%. So that's 70 or 80% of data scientists' time doing things like, just ordering data in the right way before doing any analytics on it. And especially in the ocean space, there are sort of a finite number of data sources out there that a lot of people sort of access. And if we can speed up the time it takes for people to work with data, we think that's a good thing. So that's trying to be like where we add our value. And of course, so there are, as mentioned, there's lots of sort of good initiatives out there that sort of put data into the world. But we also, we know from our colleagues who are scientists that a lot of data just doesn't really end up in global repositories, that it just sits on personal laptops or hard drives. And even for big companies, that's the case, that they collect huge amounts of ocean data and they just leave it on a hard drive, because once they've used it, they've done with it, and they're like, well, that's it, that's done. And one of the sort of things that we try and do is to say, okay, well, let's take that data and put that out into the world in a way that's really easy for people to work with. And that's why we've been building the Ocean Data Platform. So it's a cloud-based geospatial platform for sharing, using, and basically sharing and using ocean data. Actually, those two things kind of sum it up pretty well. And I'll do a little demo on this. And I wanted to give well, there's the architecture slide, which I won't hang over. The benefit of it being cloud-based is that it's scalable, so you can kind of, you can do everything from you would do on a laptop all the way up to what you would need to use a supercomputer for. That's the nice thing about cloud-based approaches. Data pipelines that we have can be updating, so that when you get data from our catalog, you know that it's the most up-to-date data possible. And that's something that we work really hard on, is making sure that we have good data pipelines so that users can come and get data and it's up to date. We also have access through API is our sort of predominant way of using data at the moment. That allows for a lot of flexibility in how people use data. I can come on and talk a little bit about that when I do the demo, maybe. But the environment is also kind of set up to go, so you can kind of just log in, find the data that you want to work with, go into the workspaces and start using it. We sort of have a very strong support for the FAIR principles, so findable, accessible, interoperable, and reusable. I guess that's probably something that's been covered already in the summer school, but I think it's just important to say that is incredibly important, being a data platform. So we do try and figure out how we can be fair in the world that has lots of different standards. That's something that we sort of try and address, and so sort of leveraging metadata, catering to the user's requirements, and as much as possible using open source components that kind of allow people to collaborate with known repositories and things like this. I wanted to share with you a specific example of something that we've done, which is, I mentioned before, this kind of like focus on one, making data easier to work with, and then two, bringing data to the world that hasn't really been seen before. And so this is an example of a project that we worked on this year with a survey company called PGS, who mostly operate in Brazil. And PGS collect a huge amount of data on different ocean parameters, but today I'll probably focus mostly on the biological aspect. So they're required by law to observe marine mammals and turtles. And if they spot a marine mammal or turtle, they have to stop their operations and wait until the area is clear. So as a result, they have this huge data set of observations, which they just kind of have to collect that because that's part of their operating requirements, but they don't share that data beyond their own use case, because for them it's kind of like once they've collected it, it's useless. And it just so happens that they actually do keep a record of it, and it's good for us because we started speaking to them about a year ago and tried to convince them, and they actually were quite sort of enthusiastic to sharing this data with us. And so what we did is we worked with them to look at what data they already had and see how we could bring that sort of data to the world. And so I just wanted to give you a very sort of whistle-stop tour of what that looks like, and why we think that what we want to do is solve this problem for people, so that when somebody wants to come to use that data, they don't have to do the following steps, which can look very messy. So yeah, as I say, this is the kind of data that they had. They have huge quantities of biota data, of current data from ADCPs and CTD profiles, and this is just a plot on our platform of what that data kind of looks like. And actually, this is a sneak peek of like what we're able to do once we've harmonized that data. Because when we first got it, we were just given a bunch of files that looked like XLS files, PDF files with all different kinds of names and all of this kind of stuff. And what we tried to do was just harmonize that in a way that makes it very easy for a user to go in and sort of find the different types of data that are now available on ODP in a much cleaner way. So even just like cleaning up those file names and things like that was a job. And that was kind of phase one of providing access to the original data. But then we thought, you know what, we could probably do better than that. Just having an XLS file is kind of good, but you can do a lot more if you do a little bit more effort in structuring that data in a way that makes it queryable. So what we then did was convert all of those files like XLS and PDF files into geospatial data points. And that meant that we had to standardize the data. So from say different file sources, different data types, we had to harmonize that. And this is just a kind of like example of what that data looked like before. All of those XLSs, of course, weren't standardized, so they were all in different formats. And again, if you wanted to go in and do any analytics on this work, you'd have had to do this yourself. And so we thought, no, if we do this, then anybody can come and they can just have a nice table with everything formatted in a good way, and it's a lot easier to work with that data. And so that's what we did. And we showed at PGS this, and they were kind of like a little bit blown away because now they're also able to go back and use that data in their own work in a lot easier way. Maybe I just before I do the demo of the platform, maybe I'd stop there and just ask if there are any questions already.
Is there any questions? No? Okay, we can start with the demo then.
Cool. Okay. So then I thought what I'll do is I'll just show you what the platform itself looks like and how that kind of working with that data in practice looks like. So it's going to take me a second to figure this one out. Right. Okay. So this is the front end of the platform. And this is once you log in, this is what you're greeted with. So we have a couple of things here that I'll just sort of navigate around a little bit. So we have a data catalog, and this is data that we have ingested from different sources, or in the case of PGS, brought to the world for the first time. And so you can sort of look through that and look at the different types of data that we have. And we've only really been populating this catalog in the last sort of 6 months or so. So it's a relatively new data catalog, and we work sort of hard that we kind of release a new data set almost every week or every few weeks. In fact, last week we just released this list of seamounts in the world oceans, which we found, and we thought that's a very interesting data set. We'll put that on the platform. But we also have like strategic partnerships with organizations like Protected Seas, and Protected Seas has a global data set of marine protected areas. So you probably won't see the sample of data here because it's quite big and complex, but what you do is you get a lot of the details behind it. You also get the kind of the API unique identifier, and that kind of comes in handy a bit later on. The PGS data that I've kind of mentioned looks a little bit like this. So you have a data collection, and within the data collection you have these raw observations of the file types that I mentioned. So this is the original source data. So if you wanted to go and investigate that, you can download it, or you can, as I say, grab the API unique identifier and sort of get working with it in a Jupyter Notebook environment. But then, for example, like this is the marine and mammal turtle observations. And so here you can kind of see this is what the sample data looks like when it's cleaned up. And you can kind of like even go in and have a look at where that point data is. And if that was a polygon, you'd see what the polygon looked like on a map. You see like the area there. And again, you can grab the unique identifier, and I'll come back to that. So that's the kind of the catalog that we curate. We put data in there that we think is useful, and we always ask people who use our platform, what kind of data would you like to see in there? And then we have like a backlog, and we try and work through that backlog and get that out to people. You're also able to upload your own data to the platform. So you can see here that I have quite a lot of like my own private data collections, and I'm a little bit unique in the sense that I have privileged access to some things which aren't in the catalog yet. So for example, we have a project with WWF that we are in the process of transferring that data onto our catalog. But here's a place where you can kind of like create your own data collection and data sets, and that you can just work with yourself, and you don't have to share it directly into the catalog, so that it's just for you kind of thing. And you saw an Iliad example there as well. We also have Workspace, and so this Workspace is a Jupyter Notebook environment, if any of you are familiar with that. So it's quite a common tool for data science to get going. And this is where it's not gonna work. I knew that this would probably happen. So this is just a script that I put together to sort of show how that PGS data would be complementary to other data that exist in the world. And so here we have the unique identifier from that data. So you're just pulling it through and querying a specific, I think that was humpback whale, if I remember correctly, but that was a few months ago. And I'm not great on Latin names of animals. And then you can just get all of the data on humpback whales from the data set. And then you can plot it. Yeah, here we go. It's not going to work. I knew that there would be some issues with it. I also kind of like put in my own obis data into there. So again, put in some humpback. Well, actually, it was all marine mammal data from obis. I put into my own personal collection of data because we don't have that in the catalog yet. But you're able to then query in the same way for humpback whales. And I think I did a boundary box as well to just get the sort of data for the relevant area. And then you can, this is where it's not gonna play nice with me. It's gonna crash out. These maps normally come up with some dots of point observations. And again, if that actually was working, which maybe I can get it to work if I open them. There we go. So here you can see like that data kind of collected in. Actually, it's a slightly different map, but here you can see the sort of overlay of data with marine mammal observations here, and actually coral reef data as well from the Allen Coral Atlas is also here. So it's kind of like relatively easy to get going. Like there's a little bit of a hurdle to get over to sort of get using that API and stuff like that, but as soon as you do, it's very it enables very rapid development well, this is a very simple thing because I'm not a very advanced data scientist, but you can get going and doing some quite interesting things. So that's the platform. That's kind of what we do. In Iliad, of course, we support those projects that want to use a platform like this, and we're actually organizing a hackathon in September, which I think I'll be talking to you about on Thursday, so I won't say too much about that, but just as a preview, we're looking at how we can support projects and teams in that hackathon in Iliad and beyond in working with data and sort of bringing it to life. So that was kind of a little bit from me. And then I was very happy to take questions or just have a discussion.
Yeah, we have several questions here. Either of you? Yeah, come. You have to come here for the microphone.
It's very disconcerting seeing yourself on the screen as well, by the way.
Yeah.
But
Hi
there.
I'm sorry, everyone, but this is more for a personal use. I work in NIVA in Norway. So since you are based in Oslo, I saw that you have information from the Methodologies Institute. I was wondering, do you have the OneNet data set included in the OceanHub, the one from EU Directorate, the Norwegian Environmental Agency, all the data that is registered for oceanography? Phytoplankton, all nutrients, temperature, all the sensors, they register it in the NVE, not in the in OneNet. But it's
I don't think we do. I think we might have that in our backlog of data sets to investigate. So just to sort of just can give a little bit more context in how we sort of decide and prioritize which data to put into the platform. So as I mentioned, one thing is we hear from users and people say like it would be great if you had this data set, this is what I need to use in my work, and that kind of like is the typical first place where we go and say, okay, that's good.
No, my question was because it's the Norwegian Environmental Agency, it's public data. The only problem is that to access it's a little bit complicated, and if someone could actually have that already ready together with other kind of data, like the one from the Meteorological Institute, it would be better for researchers to just access this.
That's wonderful to hear. That's exactly the kind of thing that we like to hear. It's a little bit difficult to hear, like the microphone's a bit difficult. So if I think I might have my email address, but if not, I'm happy to for you to sort of like just contact me and just give me some more details about that. And if you're in Neva, come and say hello and we could talk about that, because that sounds like a really good idea. Yeah, great.
Okay, well, thank you.
Thanks.
Thank you. I think we have another question. Yeah, thanks for the presentation. My question was more on this operations on the data to get from the individual data sets to one big data set. Like, for example, I use the GlodeUp data set that you also showed us. And I know that there's often a lot of individual ways that it gets chemically measured, and then there are probably a lot of conditions which I don't necessarily know because I do modeling, but I know that for the at least the chemical measurements, it's quite individualistic. So how did you treat this data cleaning to basically like standardize it and mix it and make sure that that's all compatible? For example, there's also often maybe different units or different conditions,
Yeah, that's a really good question. Typically, we try and stick to as close as possible to the data as it comes originally to us. I don't know specifically for the GlodeUp example how we approach that, and so I don't have a great answer to your question. One thing that I would say is in the Iliad project, and again, I'm not sure if you've had this presentation already, there's some really good efforts ongoing to do semantic harmonization of metadata and standardizing descriptors of data. And so that's, we kind of follow that work within the Iliad project and see how that could be applied in the work that we do as well. As I say, for now, I believe we just try and represent the data as it comes to us. If we have to take a judgment call on sort of harmonizing or picking a data type, then we try and follow one of the best practice examples that we might look for. But yeah, it's an extremely complicated topic, but it's a really important one. It's a really good question that you ask.
Yeah, but there's probably then there was also some like individual, like one expert on, for example, then biogeochemistry and was then converting everything, right? Probably. Like you still have to do somewhat individualized, I guess, right? That was more
we do have to do that. Yeah. We do have to do sort of conversions. Otherwise, it doesn't really work. And I guess that's like one of the things that we try to do is again, like, as a judgment call, but we think that the value in having like one standard is better than sort of a data set with a mixture of different standards. And so like we probably would pick, and I'd have to ask our data team like how they do that process, but we would have to pick a standard and say like that's the one that we're sticking to. And as long as we are very transparent on what we do and what we show, then I think that's an acceptable solution. But yeah, that's a really, really tricky thing that we do.
Yeah, thanks. No, that's just a lot of questions. Thanks.
No, thanks for the question.
Thanks. Do we have any more questions? No, I guess not. So thank you very much.
Great. Well, thank you for having me.